Welcome. My name is Cecil Juma. I would like to take you through a topic, linear programming. In today's lesson, we are just going to introduce this topic, linear programming. In life, you will discover that it's all about business, it's all about economics, and in these terms, it's all about achieving more while you use less, trying to get more while you use less effort, and that process is called optimization. So optimization is a process that mainly focuses on minimum cost while achieving maximum profit, or you can use minimum resources to achieve maximum profits. So optimization, it's a way of life. Ndi chimene muyenera kukhala in your day-to-day life, using less resources, using less energy, but achieving more results. So that is what is all about in our day-to-day life. You get money, use that money in a way that you achieve more results. You get your salary, use that salary in a way that will give you more results. So that is what we call optimization. So this optimization is very important. It's a tool, it's a thing that we have to live it. It's a thing that we have to know it. That is to say, before you do anything, you have to think, how can I use this to achieve more results with the little that I'm putting in? So there is a method to do this, and that method to help us achieve higher results from less resources, to help us achieve higher results from less energy. This method is what we call linear programming. So linear programming is basically a tool that we use to achieve optimization. So in other words, linear programming is just an optimization strategy. It's a strategy that helps us to achieve more, to get more profits from the less input that we can put to a thing, whether a business, whether in our studies. We use less effort but get more results. So there are a lot of methods of trying to achieve optimization. There are computer softwares which we can use to get more results, to optimize. So in this lesson, at your level, we are going to use a tool what we are calling linear programming. So linear programming will help you determine what you should put in a process, what you should put in your business, what you should put in your studies, with the intention of achieving more with the less time you have, with the less resources you have, with the less energy you have. So linear programming is very important in our day-to-day lives. Whenever you are living, you have to think of, what can I do with the situation I have, with the intention of achieving more results? So linear programming, in a nutshell, is a method of determining optimum values of a function subjected to constraints expressed as inequalities. So in here we are having this term constraints. Constraints are just limitations. that you may have. So you may use that limitations, you may use those limitations to achieve what you want to achieve. It could be an issue of time. You can have limited time, you can have limited resources, you can have limited money. So those are constraints. But these ones are usually expressed as inequalities. By now, you should understand what inequalities are. Let me give an example. You can say that you have, let's say, 300 or 3,000 kwacha. But from this 3,000 kwacha, you need to do business. Let's say you want to sell sweets and biscuits, or sweets and kamba. So you may be able to determine how many sweets that you should buy, how many kamba that you should buy using 3,000 with the intention of achieving your results. So what we do here is we put up a constraint. We all know that sweets can be represented as X, kamba can be represented as Y, but all this should be less than 3,000 because 3,000 is the only money you have. You can add some other constraints to say, okay, muna maswiti ndugule osabitilira maybe 2,000. You can say kamba less than 1,000. So you can play around with this. These are what we call constraints. Ndizimene zikupanga ni guide, zingakupatsa ni guidance with the intention of achieving the same results with the minimum resources that you have, with the little resources that you have. So this is what we call constraints. So in practice, functions to be maximized often represents profits or volume of goods that can be input or produced, while functions to be minimized can be production cost or production times. So what this statement is saying is pali zinthu zimene tikuyeneka kuzichulukitsa komanso pali zinthu zimene timayeneka kuzichepetsa. So we use these optimization methods to allow us achieve more. We use this optimization method, which is linear programming, to allow us use less resources. For example, we can use this method to achieve more profits. Okay, if we are keeping Zintu, whether in a warehouse, we can keep more volume of goods by using this optimization method. Or we can use the same method to use less energy while achieving more. We can use the same method to reduce cost. Yazint. Okay? Let's say mumapika mandasi. Okay? Kuma mandasi aja mupike, you need the flour, you need the nkaiwa. Okay? You need the ufa, komanso you need the flour. Musaganiza and achieve mandasi, let's say okoma. So how should you mix them to achieve this objective of producing mandasi okoma? It's all about optimization. So at your level, at this level, MSCE, we use linear programming to achieve those objectives, to optimize. So There are a lot of methods that you can use to optimize, but at your level, you use linear programming. So we have softwares, computer softwares can also help us to optimize. Computer softwares will allow you to have more problems, to have more constraints, to have more variables to optimize. So, but this one gives a very good basic ground for you to get prepared in near future, for you to get prepared in different courses which uses optimization. So simple problems with only 2 variables may be solved graphically. Okay, so at your level you have 2 variables, and those ones can be solved graphically, can be represented as x, can be represented as x and y. So you may have those 2 variables representing, let's say, offer or flower, things like those. So for you to minimize a function subject to a given constraint, that is inequalities, require a permissible solution, permissible or allowable solution, usually called a feasible region, to lie in or on the boundaries of that feasible region. What this statement is saying is simple. Chifukwa chanena kuti muli ndi ma constraints, muli ndi malire amene mungathe kuchitira zinthu. So for you to achieve optimum results, you need now to consider a region. Okay? You need now to consider a region. So we are saying my constraints are represented as inequalities. You can have more or less. Okay? You can have a certain region. Okay? My inequalities, if you are learning program. So you may have this region represented as a triangle. You may have that region. So this region, this could be profit. This could be cost, isn't? So based on my variables, you find out that you are having my inequalities, but you will remain with a region. So this region, every point on this region could represent optimized results, could represent maximum profit, could represent less cost, could represent a lot of stuff. So this is what we call a feasible region. Region imene mungathe kupezamo ma results anu. So could be makonomu. Any point you take in this area, you will achieve the required results. So let's continue. Now, constraints are usually limitations on resources. Okay, constraints, we are saying, are just limitations that you have in real life. Limitations in cash, limitation in production capacity, limitation in time, limitation in manpower, limitation on machines, limitation on whatever you have. And these ones are usually allocated among various competing variables. Now, a feasible region is the region that will contain all solutions of the system of constraints. The ordered pairs within the feasible region are known as feasible points. Okay, so if you look at this one, you can have different points. Okay, because this one is a 2-dimensional space. So you can have A, could you have maybe point X and point Y. X1, Y1. B could have x2, y2. The same with C could have x3, y3. So that ordered, those numbers, those points within a feasible region are what are known as feasible points. We will understand them more when we look in the next lesson on how we can do this, on how we can come up with feasible region. So reaching this far, I think for introduction, we should stop here. Let's meet again in the next lesson where we'll expand more on linear programming. Thank you. See you next time.